Rob is kind of coming back to his roots. He's a CMU alum. After graduate school, he went and he joined Microsoft Research when it was much smaller than it is today, where he's now a principal researcher. And he's going to tell us today about a really interesting direction that he's taken, applying these user-centered approaches to looking at how data scientists can analyze live data streams. So Rob, welcome. I'm going to turn this. Do you know how to turn this one on?
How are we for sound now? Okay, great. So yeah, I'm actually very happy to have the body mic because the giant mic makes me think of karaoke, and that, trust me, is a thing you do not want. So I'm really, really excited this morning to be able to talk to you about this topic. It's a relatively new topic in academia. There are very few studies on data scientists, and so I'm eager to kind of socialize this topic with the academic world in the hopes to get more of you to kind of jump on the bandwagon and join me in studying this group of people. So I'd like to start the talk by addressing the elephant in the room. Big data. You'll notice this is a phrase that is conspicuously absent from my title talk. Big data is certainly a hot topic these days. It gets lots of press coverage. I'm curious, just sort of a show of hands, how many of you are sort of tired of the hype around big data these days? Yes, so good news, me too. So if you thought this was going to be some kind of like TED Talk where I was going to stand and tell you about all the wonderful wizardry that we can do with big data and save the world and hyperinflation, blah, 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 this is not that talk, okay? So this is a much more nuts and bolts kind of talk in which I want to just tell you exactly how data science works in practice. Basically, the way the press treats big data today is a bit like this, right? You know, it's wondrous and huge and very scary, right? And today, I don't really want to focus on that part. I'm really much more focused on the data scientist behind the curtain, right? So we want to focus on this person. I want to tell you what data scientists are like. I'm also a tool maker, as Gail's lovely introduction mentioned. So I've spent about last 25 years making tools for people who do technical work. So I'm also super interested in the tools that are behind all the technical wizardry, right? And by the way, I totally need to make, you know, steampunk big dials and big switches to throw as part of my demos. That would be so cool. And then finally, what I want to tell you about, and I apologize for stretching the movie metaphor beyond its breaking point at this point, but I also want to talk about the other stakeholders that are involved in working with big data. So as I said earlier, in terms of academic literature about data scientists and data science, there isn't a whole lot. There aren't very many papers you can go out there and read to find out what data science is like. So as a result, some collaborators and I, Miriam Kim from UCLA, Tom Zimmerman and Andy Bagel also from Microsoft Research, we basically have started to do some empirical research trying to find out what is the life of a data scientist like. So the study I want to start with this morning is an interview-based study that we did about a year ago where we interviewed 16 data scientists all at Microsoft and taken across the entire company. So I've listed in a very high level, the different kind of products they come from. And so they come from all over the place. And the interesting thing is data scientists these days are a little bit hard to find. If we want to talk to developers, well, that's easy because their job titles tell us that they're developers, and so it's easy to go and find them. At least at Microsoft, there are no consistent job titles right now for data scientists. There are no mailing lists that they're all guaranteed to belong to. So we did something called snowball sampling. So this is a method where you start with people that you know are in the population that you're interested in, and it was easy to find the first few. And then you basically use their social network to find the next set, and then you use their social network to find the next set, and so on. We did enough interviews that we reached what's called theoretical saturation. So we kept talking to more people, until we started hearing the same stories over and over again. Even with just 16 interviews, we had a pretty good sense of what the state of the practice of data science at Microsoft was. So let me tell you a little bit about it. So the main thing that we got out of this study, and I'll just briefly mention that the work is currently in submission, but in anticipation of this talk, I put it out as a technical report. So if you're interested, there's the technical report number. So I encourage you to read it. We would love feedback. So the main finding that we had in this study was that we noticed a cluster of basically 5 different working styles of data scientists. Now, the way that you should think about this kind of qualitative research is, sort of picture us as explorers going up the Amazon and collecting butterflies, right? So these are 5 different species of data scientists that we encounter. Are they the only species of data scientists? Probably not. There are probably others out there. But at least now we know these 5 exist. So I want to tell you about these 5 different kinds of data scientists to kind of give you a sense of the different ways in which this job impacts software teams. So let's just go through them one by one. So the first style that we have is the insight provider. If you know anything about data scientists, this is probably the role that you think of. An insight provider is somebody who is part of the team and basically sits in between the management of the team and the engineers. So the insight provider is going to work with the engineers in order to gather the data that's necessary to answer the questions that the team leaders have. Right? So this is sort of an interfacing job. And really the point of this job is to help the leadership of the team make informed decisions, make informed choices for the team. Because it's sort of an in-between kind of role, these insight providers tend to have very strong communication and coordination skills. And on each one, the paper actually has quite a number of people in each of these roles, but I'll have like a little selective quote from each participant on each slide. So this one, this particular, and they're anonymized, so that's what P2 is about. So this person was sort of tired of the engineers just sort of throwing data over the wall saying, hey, can you make something of this? And emphasizing the fact that there's coordination that's required. Now, the next working style here is basically like an inside provider, but on steroids. So this is somebody who's an inside provider, but is in fact also a manager of an entire team of data scientists. So instead of being an individual fulfilling the role of an inside provider, now we have an entire team of data scientists doing the same thing. And as you can imagine, because we've scaled out to a whole team, this kind of data scientist is tackling much bigger problems than the individual data scientist is. One way of thinking about it is they're working on problems where a lot more money is at stake than the individual workers. Also, at least at this stage in Microsoft, a lot of these very senior, high-level data scientists are also acting as evangelists, trying to spread best practices about how to do data science. The next one is the most kind of low level. So this is a data scientist as engineer. So a big part of data science are things like data collection, for example. And data collection requires writing software and requires thinking very carefully about trade-offs, for example. So, you know, how much data can I afford to gather because it has runtime costs, for example. As you can imagine, this person has very strong background in engineering. So this is somebody who's a really good dev, as well as probably being a statistician. The third one is a little bit at the opposite end of the spectrum. So this is somebody who is a really world-class statistician or machine learning specialist. So this is somebody who, the ones that we talked to were pretty much machine learning specialists. So they are experts in data modeling. They know, every kind of classifier there is out there. They have lots of experience about how to figure out which features you want to use based on your classifier and so on. And because they're such experts, they often sort of float around and they act as consultants, kind of going around talking to other teams, making suggestions about the best way they can do their data analysis. And then the final one is the polymath, or sort of the jack of all trades. This is basically somebody who typically works in isolation somewhere, and often somebody who's doing data science based on his or her own initiative. So this is somebody who has an idea and just wants to use data to explore that idea. And because they're working in isolation, they kind of have to do it all. So they have to do the engineering work to be able to gather the data they need. They need to be good enough statistician, machine learning, data analysis person to be able to analyze the data and draw conclusions from it. They need to be a good enough communicator to be able to be persuasive that this idea is going to work out. And so they basically, wear all the hats. So there you have it. So those are kind of 5 different working styles by which data scientists accomplish their work. Of course, I haven't told you what that work is yet. So, what kinds of things do they actually analyze? What are their goals that they're trying to do? Well, there's a variety of them. So one kind of very crude split, we could say, is we could say there's some backstage problems that they work on, and there are some on-stage problems they work on. So backstage, they're going to do things like help the team figure out whether their services are healthy. Are the services running well or not? What are our customers up to? Which features do the customers like? Which bugs should get the highest priority? This kind of thing. Some of the on-stage ones are some of the oldest uses of data science. So probably the most famous type of data science would be something like internet search, right? So Google has made a fortune out of data science, right? Because they're doing lots of machine learning in order to serve up great search results, in order to serve up great ads. So there, the result of the data science is actually directly shipped to the customer as a feature, right? You're experiencing those search results and their ranking and so on. You're experiencing those ads and their relevance to you. So those are kind of the on-stage things that data scientists do. So that's like a super high-level kind of view of what data science is about, right? So now what I want to do is sort of take things lower level and give you a sense of what it's like to be a data scientist on a day-to-day basis. And the way that I'm going to do that is a little bit of pretend, right? So what I'm going to do is I'm going to pretend to be a data scientist for you and just sort of walk you through what the day-to-day work of my day-to-day practice is like. So I'm a data scientist now, and I work on a games team. I work on a team that makes mobile phone games. And in fact, we make very sort of the highest in its category mobile phone games. And what is that? Why? It's Kitty Pong, a game that combines the internet's obsession with cats with all the fast-paced action that is Pong, right? No wonder it is a bestseller in its category. So Kitty Pong, as you can tell, is a competitive game, highly competitive game. And right now, the team only lets you play Kitty Pong with your friends on your social network. And the teams had this idea, wouldn't it be great if you could play with anybody, anyone on the internet, any Kitty Pong player. But it would be most fun if you play with somebody who's kind of roughly at your skill level. I'm not sure how much skill Kitty Pong involves, but it'd be nice if you were not an expert that was matched against a ranked beginner or the other way around, right? You want to be roughly even with the other players. So this is the agenda for thinking about that. So step one, I as a data scientist am going to help the team make the decision about whether this skill matching is going to work out or not. We think we want it, but we're not really sure whether it's feasible. So that's number one. I'm going to go figure out whether it's feasible and help the team make the decision. So this data-driven decision making is also called analytics. So that's kind of step one for me. Step two is if we decide we want this, then I'm going to help the engineers deploy the feature. And part of deploying is that we want to not just launch it, we want to actually test it in practice first. So we're going to do something that's commonly called A/B testing or sometimes called flighting, which is we're going to give it to a select subset of the customers, let them try it out, and figure out whether it's going well or not. And then finally, after we've fully deployed it, assuming we do that, then I'm going to help the team monitor the usage of this feature in order to basically tell whether customers are liking it or not. Okay, so I want to walk through each of these in turn. So the first one is deciding, kind of a go, no-go decision on this feature. So how am I going to do that? Well, first of all, the team so let's see. So the very first step that I would like to do is a step that's called exploratory data analysis. And this is a term that goes back to John Tukey, who's a very well-known statistician. This is a book that he wrote in 1977, and given the hotness of data science right now, this book is unfindable. So if you can find a copy in a used bookstore, keep it, because the price has been skyrocketing lately. Okay, so the basic point of Tukey's book is that you shouldn't just rush into fancy statistics. So don't start by doing, a regression, or don't start by doing, some sort of correlation or whatever. You really should look at your data, right? If there was a one-sentence summary of this book, it's look at your data, right? So the very first step I want to do as a data scientist for helping the team make this choice is I want to look at the data. So in order to do that, I have to start with a sample, because I want to take a good look at this data. I want to really thoroughly visualize it. And most tools for doing that can only handle data up to a certain size. Now, because of the enormous popularity of Kitty Pong, we just have bucket loads of data, right? Way too much for me to realistically visualize. We keep all this data in Hadoop. So the first thing I'm going to do is write a little script in something called Pig Latin, which is a high-level language for analyzing data in Hadoop, and among the commands that it has is one for getting random samples. So here I go and I get a random sample of data about the players and data about the games. Once I have my data sample, very typical next step is I'm just going to pull it into good old Excel. Many times we heard that Excel is like the scratch pad that data scientists use. In the same way that a programmer might use Notepad or might cat something to a shell as just a way to take a quick peek at what's going on, data scientists use Excel in this way. And of course, I'm sure almost everybody in the room at some point or another has used spreadsheets. So I don't have to tell you what this is about. I'll just say that kind of the tabular presentation of the data is one of the reasons they like it, because the sort of data to pixel ratio is really good in a spreadsheet. It's right there in your face. And of course, with a few button clicks, it's really easy to get summary statistics like histograms and things like that. So this is part of exploratory data analysis, is really taking a good look at the data. An alternative that may be less familiar to you would be a program like Tableau. So Tableau is a desktop app or a web app made by a company of the same name. It's not a Microsoft product. Very nice product, though. So let me give you a sense of how Tableau works. So you load in your CSV or something like that, just as you would into Excel. And then you can very quickly and fluidly switch between visualizations. So is the mouse visible there? Hopefully a little bit. So you can very quickly go and choose different kinds of visualizations. So say I want a scatter plot, and then there are ways of binding columns from your data to different dimensions of your plot. So if I want a scatter plot, I'll say this is going to be my x dimension, this is going to be my y dimension. I'd like the size of the dots to be this third dimension. I would like the color of the dots to be this fourth dimension. And it's all very quick and fluid. With a few clicks, you can be quickly looking at your data. So whether I use Excel or whether I use Tableau, I'm going to do this exploratory data analysis to figure out what games data do I actually have. What are the columns that represent the player and the columns that represent the games? Do they have enough information in there for me to actually do the player matching, right? The columns that I'm interested in, is the data present, or are there a lot of missing values? If they're present, what's the distribution of the data? Is there enough difference in the way the players look in the data to even think about having different skill sets? So I'm basically taking a very early peek just to see if it's even plausible for me to do this feature. So let's say it is. Let's say the columns are in there that look pretty good. My next step is likely to go into something like R. So this is a screenshot of R Studio. So I'm curious, how many of you have used R before? That's what I would have thought. So it's a fairly popular tool, particularly among academics. And so most of you know it pretty well. One of the reasons why so first of all, it's a scripting environment. And ultimately what I'm trying to do is produce a player matching algorithm, right? So if I want an algorithm, I need some kind of programming environment. So this is a nice scripting environment for that. And it just has this enormous universe of different libraries that go with it, including plotting, data manipulation, statistical tests, machine learning, and so on, right? So this is going to be my next step, is brainstorming for this algorithm in R to see, again, whether I can get good matches that make sense to me or not. Now let's assume that I've done that, and I've got an algorithm I'm pretty happy with. I've only done the algorithm on a sample. Remember, I took the sample earlier. So now I need to see whether that is going to work out at a larger scale. So I need to go and see whether the algorithm I've come up with will actually run on all of our data and not just the sample. So now I'm going to go, I wanted to briefly mention before that you all know R, but I wanted to, again, mention a very popular alternative. So has anybody in here used IPython Notebook? Quite a few hands, more than I expected. So it's basically a Python programming environment crossed with a notebook like Mathematica, for example. So the steps you do are all captured on this kind of written page and kept. But it's, again, the thing that's great about Python is this vast array of libraries for doing plotting and data manipulation and so on. So they're both very popular for doing this kind of algorithmic brainstorming. Okay, so I've got it to work on my sample. Now I need to go back to Hadoop, right? So This is, again, Pig Latin, one of the scripting notations that's available for Hadoop. And what I'm going to be doing now is basically writing some SQL-like code at the top. So it's a kind of mixed notation. So the top is going to be my SQL-like code for going and getting the player and games data. And then the algorithm for matching players that I came up with in R, I'm now going to write that down in Java. And there's a sort of foreign function call between the high-level SQL and this lower-level Java, right? So notice that I brainstormed the algorithm in R, but in order to get it to work in Hadoop, I now have to rewrite it in Java. So I'm now going to run this, this thing, and Hadoop is a batch system. Now, because my games company is a big games company, and there are several data scientists, I'm going to have to wait 4 hours before this scripting code even gets scheduled to run. And then when it runs, it's going to take 6 hours to complete. So basically, I submit this, and that's it for the rest of the day for me. I'm going to go do something else, because otherwise I'd just be sitting there waiting. And heaven forbid that I, for example, did an inner join when I meant an outer join, or even made a syntax error in this. Because, well, syntax would probably be caught early, but these more semantic errors, this thing's not going to be scheduled for 4 hours. So I'm not going to find out about errors for a long time. And I'm just going to have to start all over again if I messed up. OK. So now we've scaled out. We've seen my games algorithm is going to work really well at the full scale of all of our data. So now as one last step, I'm going to take the output from my Hadoop job, and I'm going to load it back into R. And now I'm going to do ggplot or some kind of plotting library in order to make some nice persuasive graphs of the kind that you guys put in your papers all the time. So you're familiar with this part. And I'm going to take that and I'm going to put it in presentation software like PowerPoint. And then I'm going to go have a meeting with the big bosses to make this persuasive case that, yes, Kitty Pong is ready for player matching. OK, so all of that was step one, the kind of go, no-go decision. The rest I'll talk about a little bit more quickly. So with step two, I really just wanted to emphasize that when we go to deploy, I may have to implement that algorithm yet again. So if I'm lucky, our games backend is also written in Java, and so that Hadoop Java code that I wrote, I could reuse. But if our backend is written in something else, this is going to be my third implementation of that algorithm. So that's all I wanted to mention there. In terms of the flighting, in terms of peeling off a certain percentage of our players to let them try it before we release it for real, I will also be involved in that, right? So with flighting, I'm going to help design the experiment because a data scientist is a scientist. And so I'm going to know about things like how to deal with controlled experiments, how to, say, minimize the confounds in the experiments so that we know when we see a difference in the game behavior, it's due to this new introduced feature and not something else. And again, in order to look at the difference in behavior, I'm probably going to load data into R, and I'm probably going to do things that you're familiar with, right? So I'm going to do, I don't know, chi-square tests or something to figure out whether there are differences in behavior between the two groups. And then finally, assuming that everything's gone well, the players like it, and we're going to really deploy this thing for reals, then again, for the fourth step, I'm going to work with the engineering team. I'm going to instrument this new feature. So how often do people use it? How often do they get matched with people? How long do those games last? And so on. And then a very typical last thing is to create a dashboard. So this is, again, a very common kind of data scientist activity where you take this ongoing data that you're gathering about customers and you make it available often on a web page so that the whole team can go in and monitor usage of this feature. OK, so that is perhaps an excruciating detail. Maybe it was too low level. But I've given you a sense of the tools that data scientists use and kind of the different steps that they go through. Now, when I was hearing about this from data scientists for the first time, my first thought was, this kind of work sounds awfully familiar. This kind of experience sounds very familiar. It actually reminds me of the mainframe era. So, think about what I told you as part of the work practice, okay? So there are things like waiting a very long time for batch systems to complete big jobs, right? That was in the mainframe era. And I'm having to cobble together a workflow out of like different tools that were not necessarily made to go together. And I'm doing things like saving data out of one tool and loading it into another tool. So it's extremely clerical. And part of this clerical work is that I have to be very rigorous, very diligent about the work that I'm doing. And I know you all can relate to this. So here's a situation I know almost everybody in the room has been in. Perhaps you were in it for this very conference. So you did some experimentation, you did some analysis, right? You produced a whole bunch of files. You submitted a lovely conference submission about the work. You got lucky, your paper got in, and now it's months later, and the reviewers have asked you to tweak something about the experiment that you did 3, 4, or 5 months ago, right? And now you have to go back and resurrect all that stuff you did. Like, where did I put those experimental files? Where did I put those input data sets? And so on, right? So you're familiar with the kind of diligence and care that you have to take of being tidy all the time so you don't lose track of things, right? That's what data science work is all about. In a word, this sucks, right? This is just terrible. I mean, we matured past this in programming tools, right? We have things like development environments now, right? So that you don't have to do this clerical switching from tool to tool to tool like you did before. We just have it much better. So when I saw, when I heard these stories and I saw what people were doing, I thought, well, okay, great. Let's invent a development environment for data science, right? So what I want to do now is give you a demo of a tool we've been working on for the last 2 or 3 years called Tempi. So this is basically our attempt to try to create something like an integrated development environment for data scientists and try to get rid of some of these kind of bureaucratic hassles that their work practice currently involves. So for the first demo, wish me luck, I'm going to try doing a bit of live demoing here. So let me reconnect to our server here. So the first thing to notice here is that Tempi is a web application. So like IPython Notebook or like Mathematica before it, it has a research notebook flavor. So what you're looking at is a notebook page that I created previously. I can, off on the left, I have a navigation bar that lets me see all the different pages I've created in the past. So let's go ahead and do a new data exploration for you here. So I'm just going to peel off a new notebook page. And because it's a notebook page, I want to help myself remember what's going on here. So I want to look at some data about some loans that have been made. So this is data I got actually from a data science course that I took, a Coursera course I took a couple of years ago because I wanted to understand better how these things work. And this was part of our homework assignment. So I did the homework assignment in R, which the instructor insisted on. Then I turned around and did it in Tempi. And so that's where this data set comes from. It's a bunch of application data for loans. There's like a lending club on the internet, and it's hooking together people who want to borrow money with people who want to lend money. And so that's where this data came from. It's a fairly tiny data set. When I load data into Tempi, the very first thing that happens is I get to see this kind of overview summary of it, right? So I get to see all the different columns and a sample of the data, the range of the data, whether the data is categorical or not, and for numeric data, sort of mean and standard deviation, as well as a thumbnail of the distribution of the data, which I can look at in more detail if I want. So you recall that step 1 was exploratory data analysis, right? So the point of this display is really to help kickstart exploratory data analysis. I know the first thing somebody's going to do is they want to see the distribution of all the columns, so we just do it for free. We also give a nice heads up about any problems we spotted in the data set. So here, in this data set, 2 of the rows are unparsable. So we give you a heads up about that. The other thing that we're doing here is a trick due to Don Syme on the F# team, and it's something called type providers. So what we're doing is when you point us at a CSV file or a database or wherever you're getting your data from, we actually sniff the data. We take a look at it, and we generate some code to act as the ingress for that data. And so the code here that got generated basically assigned a nice type, nice .NET type to each of the columns. And what this is going to allow me to do is start to do some scripting. So what I'm going to do in a very fat-fingered kind of way here is I'm just going to start to play with the data. So what I want to do is I want to look at, let's say, those loans whose loan purpose is borrowing a car. So what you saw there was that it's a regular scripting environment, right? So you saw code completion going on. You saw me getting error messages along the way about syntax errors and so on. And then as soon as I produced a good query, something that was syntactically correct, it ran and I got to see the result here. So what I did is I produced a subset of the data that is for just the cars. The scripting notation here is C#. We'll talk about why that is in a minute. And the query language is very much like LINQ. So it's like Eric Meyer's LINQ that's been in C# for a number of years now. So it's very familiar to C# programmers. So now I've created a subset. And now I'm kind of curious about what is kind of the mean car loan going on. Did I misspell it? Oh, and I have to say what I want to take the average of. So I would like to know the average of the amount requested. So there we go. So happy now? Happy now. So the average amount was 8,000. That average doesn't really tell me much. So I'm also interested in seeing the distribution of it. So again, let's look at the amount requested. And so now I can start to see this is actually the distribution, not just the mean, of the amount requested for cars. Now, when I was looking earlier at the loan purpose, so when I looked at this loan purpose, there's a bunch of reasons why people borrowed money, including weddings. So instead of cars, I'm interested in weddings. So let's take a look at how people borrowed money for weddings. So actually the amount that people are borrowing for weddings, interestingly, is more than they're borrowing $11,000 for weddings and they're borrowing $8,000 for cars, which is sort of interesting. So now what you may have noticed there is that this is a live scripting environment. So it's not a REPL like R or like Python where I'm typing in command after command. The whole thing is basically a program. And at any point I can change any part of the program. And we're smart, and we've done a dependency analysis in the background, and we selectively re-execute, rather like a spreadsheet, right? And in this environment, actually, most of these programs tend to be functional in nature, right? So people are not side-effecting the heap. They're basically just cascading one query into another. So it is very much like a spreadsheet. Let me show you, let's do one more analysis here very quickly because there's one more feature. This data set is too tiny to show you the feature that I want to show you next. So let me go ahead and load a bigger data set. So this is historical data about the NASDAQ, which is a stock exchange for largely tech stocks, right? So now what I want to do with NASDAQ, I hate typing NASDAQ. It's a very difficult word to type. Let's see. So what I want to do is let's go ahead and look at those stock prices that are sort of in the $1,000 range. And I just want to see a histogram of their opening price. Okay, so here's a histogram of those stocks. Do you notice that it may be a bit small, actually? Let me just blow this up in the browser a little bit. And I'm going to go ahead and rerun the query so that you can see the wiggling and jiggling. Do you notice that the bars are kind of moving around? And you'll see that there's a percentage down here that's going up. In Tempe, all queries are executed progressively. So even if I'm looking at, okay, so this was 8.5 million rows, that's not super huge. But even if I were looking at a really vast piece of data, we still execute the queries incrementally, and once a second, we update any of the visualizations that are on screen to show you the results of the latest data, right? So that business that I did earlier of having to take a small sample and work with a small sample, I don't have to do that here, mostly. There are some non-incremental, I'll confess, there are some non-incremental operations in our system. For example, the machine learning library that we support, many of the training, classifier training steps in that it does, and so on. Those just are not incremental in nature. Sorting, obviously, not very incremental in nature. So there are some kind of third rail operations that, you touch them, very carefully, if at all. But most things are very progressive, just like you saw. Okay, so I'm sure you are tired of seeing me type in a fat-fingered way here. So I'm just going to go ahead to speed things up and give you some other demos just kind of on video. Let me show you another feature here, which is the data that you looked at there was data that was stored, data at rest, as data scientists sometimes say. Now we want to look at live data, data in motion. So here, I'm going to show you a demo of analyzing a Twitter feed, right? So here I'm using the Twitter Garden Hose API to get live tweets. So I've executed a query and getting back a set of tweets. Since it's huge, I kind of collapse it there. And now what I want to do is use some sentiment analysis to get a sense of how people are feeling in their tweets. Here I've done a where to filter down those tweets that mention Xbox, and I'm getting their sentiment. And so what you're seeing is a timeline that is updating in real time as tweets are coming through, showing you the sentiment of that subset that mention Xbox. And now I'm going to do the same thing here, but with Skype. So this is going to be the sentiment of people that are feeling Skype. And sometimes you'll see pauses here. And the reason you see pauses is because it's live data. If nobody mentions Skype in a tweet, then nothing comes through. And then in the final step, what I'm going to do is bring these two together into a common timeline. So this is me doing a temporal join between these two streams. And then that allows me to get this timeline where both these sentiments are brought onto a common axis. And then as a last step, what I want to do is I want to take that bottom display of how people feel over time about Xbox and Skype, and I want to turn it into a dashboard. Well, in Tempe, there's just a dashboard button at the top. So I click that, and what it does is it's just an alternate view of the same running script. So we basically just display, we don't show the code, we just show those visualizations that you haven't collapsed. So there was only one, which was this dual timeline, and so that's what shows up in the dashboard. You'll also notice there's a script button kind of hiding at the top. So at any time I can click script and go back to the other view. So I can go back and forth between the two views all I want. So whereas in the previous world that I talked about, the dashboard builder was a whole separate tool, here it's just a button, and it's just an alternate view of the same script. Now, the features that I've shown you here, we had a really great customer that used Tempe. and that is the Halo game. So any Halo players in the room? A few. Not as many as there should be. So Halo is a best-selling Xbox game. And I must say the team here is awesome. And not just because they use Tempe. I mean, they're really awesome to begin with. Very smart folks. Over the last holiday season, so this time last year, they were releasing the Halo 5 beta. And they ran their beta program over the holiday season. So it started sort of in November, ended sometime like in January. And that whole time, the Tempe team was behind the scenes helping them analyze their data. So there were two things that we did with them. So one is they had a set of streaming data about the health of their services that run in the back end. This kind of, sort of server health data is often commonly called telemetry when it comes in a streaming form. So they used the dashboard features that you just saw. In fact, they requested the dashboard features that you just saw. They're the reason we made them. And so they wrote queries that displayed various health metrics about how their servers were running. They put it on a dashboard. It turns out, we later learned, they in fact created a dedicated kiosk in their team space that did nothing but show the Tempe dashboards all the time. And it became part of their work practice at the start and end of every kind of work period they had to constantly check these Tempe dashboards about whether their servers were running or not. The other thing that they did is they did many, many, many ad hoc queries about what players were doing in the game. So they didn't just want to know about the health of their services, they also wanted to know about customer behavior. How are players liking this? One of the things they got really curious about was the rate at which players were winning medals in the game. And they were particularly interested on this day when we produced this. They were interested in the really, really hard to get medals. So some medals are quite easy to win in the game, and then some are nearly impossible. So the thing that surprised them when they did this query and they produced this chart is this combat evolved medal that's at the bottom. Let me describe the combat evolved medal to you. So to win such a medal in this game, what you have to do is throw a grenade at a weapons cache, have the weapon explode back at you, where you then catch it and use it, right? Okay, this is a totally boss move that like nobody should be able to do, right? And so they did this timeline, and they saw that it was like non-zero, and it was non-zero like, multiple times per minute, right? And this was very strange to them. So then, because all of our data is time-stamped, because it's a temporal data, they were able then to like dig deeper using using Tempe to basically find those moments when players were winning this medal. So let me show you such a moment. So here's the player, and soon you'll see the grenade get launched. Here we go. So grenade's thrown, and player walks over and just walks over the weapon on the ground, right? Not the intended behavior for winning this medal. So because they were able to do this kind of ad hoc query, and because they could use our scripting environment to drill into the specific moments, they could spot this bug. It was basically a bug in the game logic. It didn't do what they intended. So the team loves us. The players, not so much, because we took away their free medal. So, oh wow. Maybe the really good players love us because now, their medal isn't as cheap as it used to be. So this is an ongoing relationship we have, but I wanted to give you a sense. They've used it for about 9 months now, but I wanted to give you a sense that this kind of design is real. We believe strongly in deploying tools to get feedback on them, and we iterated with them quite a bit. I want to show you one last super quick demo, and that is, this is a demo that's only like 2 weeks old. So I have a number of colleagues at Microsoft Research who are playing in both the Internet of Things space and in the wearable devices space. And I see them doing the same kinds of struggles to analyze their data that I see data scientists doing. So I made this little demo for them, basically to persuade them that, like as an ad, basically for Tempe, saying, hey, it might be good for wearables as well. So I'm not wearing it today, but the Microsoft Band has lots of data about heart rate, and it has accelerometers in it, and so on. And so what I did is I create a little uploader where that data gets sent through Bluetooth to my phone, where it then gets uploaded to Azure and then downloaded into Tempe. So that's what you're seeing here. And here I'm just looking at all the data coming off the band. So this includes all the different accelerometer data and so on. And this is me sort of wriggling my wrist and then not wriggling my wrist and then wriggling it and so on. So that's why you see squiggles, then nothing, and then squiggles and so on, right? Because this is what makes it really hard to do wearable device research, is that it's really hard to figure out the correspondence between what's going on in the real world, like wrist wiggling, and what it actually looks like in terms of the data stream. And because this is live analysis, the correspondence is immediate. I wriggle and I see what the signal looks like. So here I've just picked the one x-axis because that seems to have the best signal. But if you've been noticing as the stream of data has gone by, it's noisy. I mean, there are like really weird kind of aberrations in it. So I'm taking a sort of windowed average. Now my window average looks funny because, especially in this moment, because it's just as noisy as the original signal was. Oh, that's because I'm an idiot and I picked a window that was way too small for my windowed average. So here I changed the 10 milliseconds to 100 milliseconds. And then after it reevaluates, what you'll see is that it then starts to do a good job of kind of down-resing the signal. So this looks much more reasonable as a signal to process than the other one. Now, I'm trying to do a little bit of discount gesture recognition here. So what I'm really trying to do is figure out like when I flicked my wrist. So I kind of want like a 0-1 signal of like when have I done this wrist flick. And here, okay, this is cheesy. I am not really very good at signal processing, but here I just use a sort of artificial threshold to decide when the accelerometer has gone far enough that I can start to get a signal. And by doing this thresholding, I get the little sawtooth that you would expect. And this is now a stream that I can imagine hooking up some UI to, or whatever it is I want to do with this gesture now that I've recognized it. So I just wanted to give you a sort of a sense of the breadth of different scenarios that we can handle. So I'm going to wrap up in just a moment. I wanted to point out kind of things that I think we get right in Tempe's design and things I think we don't get quite so right. One of the things so for sure, a big price we paid engineering-wise in making this system is we made it a web app as opposed to a desktop app. Web apps are a pain. Okay, it's distributed systems programming, that's harder. Keeping the thing running, even harder still. So we basically wore beepers to keep this thing alive for Halo for months. But it lets you do sharing based on URLs. So if somebody does an analysis and they're happy with it, they can copy paste the URL, send it in an email to the whole team, and that's worth the price. As you saw, we have an API that supports a really wide range of scenarios. Now I can sort of tell you why C#. So that's a pretty weird data science language right there, C#, right? It has LINQ, so that makes it a good fit. But on the other hand, it's just not what people are used to. But what it does allow, so C# is one of the very common implementation languages within Microsoft. So what it allows is it allows people to copy-paste code from Tempe into their deployed system and back again. And that's super important. It means, remember when I had to re-implement my game matching algorithm 3 times? Now I don't. I implement it once in one notation. The real downside to this design is it's a programming environment. And you have to have programming skills to do this. Not only that, you have to have programming skills where you can do LINQ, which is even more. And even more, you have to be able to do our wacky temporal streaming query language, which I still, after months, find very mind-bending, to be honest. So it is hard programming, right? And in fact, this is a quote up here from one of the Halo folks. The engineer we worked with on the Halo team, he really wanted to get the program managers involved because they had lots of questions about data. And they couldn't answer it. They tried using Tempe. It was a fail. they couldn't do the query language. So basically, anytime they wanted an answer, they would have to turn to the engineer and say, can you write a query that will do this for me? So I think there's a huge opportunity here for basically democratizing this kind of technology and helping folks. And since I'm super out of time, I'm going to flip right to my last slide here. And it has to do with the business of non-experts. So these are two things that I am now pretty convinced of. So one is that when it comes to decision-making based on data, it's not just experts, it's also non-experts that really want to be able to get answers from data. And by non-experts, I mean, everyone on the planet, basically. I'm not just talking about domain specialists who don't happen to be programmers. I'm talking about everyone. The other thing that I'm very convinced of is that the conclusions that people are drawing from data today matter. And they matter a lot, right? So I explained to you how they matter in a business context, right? Teams are making really important, expensive decisions based on the outcomes of this. But I've also spent some time working with nonprofits, and nonprofits are also mining data to make decisions about how they're going to use their limited resources to carry out their missions. And finally, more and more and more, I am seeing data being used by things like governments to make policy decisions, right? In fact, an example that I've skipped because it's a whole story in its own right is basically about how a couple of economists at Harvard did some data analysis that, whether you believe it or not, supposedly inspired a lot of the austerity measures that were being enacted in Europe, right? So some people believe this story, some people don't. But the point is, we're very close to living in an age where these kinds of tools that people are building for data scientists can absolutely have an impact at a really global scale. So I will leave you with this question. This is a thing I would love help from all of you on. How can we help people to analyze the data and not just do it in a productive way, but also really be confident that the answers that they're getting from the data are actually right answers. So this is sort of a correctness problem, which you haven't seen me address at all, right? I haven't said anything about the correctness of the analysis that people are doing. But it's super important, and I think it's a totally open problem. So with that, I thank you very much, and we'll take your questions.